This is Exam 3 review, example number 4. For this problem, the bandwidth needs to be found for this particular circuit. So first, the low frequencies poles are determined by 1 over R equivalent for each capacitor, and the largest value out of those three is the low frequency value. It's stated in this problem that C2 and C3 yield a pole value that is less than the pole value for the 1 microfarad. So we're only going to have to determine the 1 microfarad for this particular problem. So to do that, the hybrid pi needs to be drawn. When looking at the low frequency for one pole, the one capacitor is left there and the other capacitors are shorted in the circuit. Looking at equivalent resistance, I'm also going to remove all the independent sources. And I'm going to draw the hybrid pi. So for the 2 milliamp source, it's a current source, so it is left as an open. This becomes a short, and I'm also going to include in here the parasitic effect of the resistance of the silicon, which is Rx, which is located here. And it says to neglect RO, so I'm not going to draw RO. And I'm going to lump both of those resistors into one. 100 in parallel with 1K, which was 98 ohms. So here's my hybrid pi, and now I need to find the pathway from this node to ground for the resistance. I see that I have a dependent source that I need to get rid of, so I'm going to use the resistance reflection rule. So I'm at the emitter for this capacitor, and so I need to reflect everything in the base by beta plus 1. So I'm going to divide all of these by beta plus 1. And R pi is a base resistor, so it is also divided by beta plus 1. This is just a floating resistor, so it is not going to be in the pathway at all of the equivalent resistance, so I ignore it. And I take a path from here until I get to ground. So I go through this plus, through this plus, through this plus. Then I have a split, so it's plus these three in parallel. So R equivalent for this case is R pi plus Rx plus 20K plus 10K in parallel with 10K is 5K in parallel with 100, and all of that is over beta plus 1. Beta is given as 100, and R pi is found from GM. R pi is equal to beta over GM, so 100 over 80 milli, which gives 1.25K. So I plug that in here. My Rx is given as 20, and my R equivalent multiplied out gives me a value of 21.4K. So now I take 1 over the R equivalent times the capacitance value, which is 1 micro, and that gives a value of 47.8 radians per second. Divide it by 2 pi to get hertz, and that gives 7.5 hertz. So this is the low frequency. To find the high frequency, I'm going to find the equivalent resistance, which is located here. Recall that C pi was located here, and C mu is located here. So I want to find the equivalent capacitance for those. So I'm going to erase the beta plus 1s. And then I'm going to short all of the low frequency capacitors. So the high frequency is determined by 1 over the equivalent capacitance seen at this location multiplied by the equivalent resistance seen also at this spot. So I'm going to call that R prime sig. So R prime sig is going to be that equivalent resistance. So that's going to be R pi in parallel with this, which is Rx plus 20K plus those 3 in parallel. So that gives an R prime sig of 1.2K. And Cn is C pi plus C mu 1 plus GM R prime L. Now R prime L is this side of where that capacitor connects, which is the collector location. So it's the equivalent resistance seen on this side. So R prime L, when you're looking into the top of this dependent source, this looks like an open. So I have R prime L is just 98 ohms. And GM is given as 80 milli. C pi is found on the data sheet as the input capacitance, 8 pico. And now C mu needs to be derived. So C mu is related to the unity gain frequency as GM over 2 pi f of t minus C pi. So plugging in these values gives a value for C mu of 34 picofarad. So plugging that in here gives the Cn value of 289 pico. And omega t then, or omega h is going to be 1 over the Cn value of 289 pico times R prime sig, which was 1.2K. So this gives a high value of 2.9 mega radians per second. Again, divide it by 2 pi for hertz, and it gives 459 kilohertz. So this will be the range. So the Bode plot looks like this, where we have a flat region, and then we know it drops off, but we don't know the exact effect and form of this, but all we really care about is knowing this value and this value. So these are good approximate ways of determining what those values are. This value was the low value of 7.5 hertz and the high value of 459 kilohertz. So this circuit operates in the frequency from 7.5 hertz to 459 kilohertz. Recall too that to define this value of the flat region, this is where you would short all the capacitors and find the V out over V sig, which is the gain from that hybrid pi. This concludes this problem.